All right, in this video, we're going to be talking about section 1.2, continuing with functions. This is going to be part 2, and this will be a much shorter lesson. We're going to be talking about something called, well, we're going to be reviewing function notation, and then we're going to be looking at a specific little piece of math that'll have some relevance later called the difference quotient. All right, so to get started, let's just do a quick warm-up, make sure we remember how to do function notation. So please, let me scroll down so you can see part D here. There we go. Let's go ahead and try those on your own and then come back and let's see how we did. All right, with function notation, we hopefully know that when we see f of -2 like this, it's giving us directions. It's saying go find this thing named f, and whatever this was, right? It's an x currently, and then it got replaced with a -2. So it is quite clearly just giving you the instructions. Hey, for this, we want you to replace the x's with -2. In other words, input -2. And so I'm just going to write in parentheses here, -2 squared minus 3, 4 minus 3, and that would be 1. Okay, we show our math going down, we show appropriate steps, we plug things in, we write problems down, etc. Now we're plugging in a half. So I'm going to plug in the half and square it. You'll notice I'm putting that in parentheses because I want the square not just the top, but the top and the bottom, and parentheses is what tells us that. So I get 1/4 minus 3, which, taking away a fourth, should leave me with 2 3/4. All right, the next one seems a little silly, but all it's telling us to do is replace the x with whatever's in this parentheses, which is all we did on a and b. In this case, all we're doing is replacing with an a. So x squared simply turns into a squared. So there's really nothing else to do. We are done. And then we want to do the next one here. So we're going to plug in, just like we did in the first three, we're going to plug this thing right here in for x. In this case, there's multiple terms. And so we get the statement, x plus h squared minus 3. So very simple. However, I do also want you to simplify this. And common error alert, like here we are, a plus b squared. We know that this is not what we want it to be, right? It is definitely not a squared plus b squared. It looks like it should be, but it is not, because this problem really says a plus b times a plus b, which we know means we have to FOIL. And the shortcut on that is very simple. We're going to square the first term, just like you did incorrectly here. We're going to square the last term, just like you did incorrectly. And the only thing missing is the middle term. And the middle term would be you multiply the two together and double it. So it'd be 2ab. Because that's what we get, real quick as a refresher, when we do FOIL. A times a is a squared. A times b is a single ab. But then I've got b times a, and so I get another ab. And when I add those together, I've got two of them. So that's where that comes from. So when you recognize that this is what you have, you don't need to show your work if you know the shortcut. All right, so how does that apply to us? We've got to square x plus h. So according to my shortcut, I should have x squared plus 2xh plus h squared, and then I've got the minus 3. Doesn't look like there's anything I can do mathematically to simplify, and so that would be the best we could do. And then the next one simply says take your function f of x and don't change it. We're just going to add an h to the outside. So don't confuse it with what we did on D. This is just taking the function x squared minus 3, which is the original function, and then we're adding an h to it. And so that would be the answer to that. All right. So all we're going to do today is we're going to go through, looks like I've got 3 examples. of using what's known as the difference quotient. Okay. And again, this has a lot of importance in calculus, and we'll talk about that at a future date. But let's just take a look at why it's called the difference quotient. It's called a difference quotient because we're subtracting on top the difference, and then there's a quotient because we're dividing. And we don't have to get into the importance of this yet. We just want to make sure we can do the math of it. So a lot of this is just really going to require a little bit of focus. So what is it telling us to do to evaluate this? Take f of x plus h. Well, what does that mean? You're going to find your function and you're going to plug in x plus h. So that would be x plus h squared minus 3. This is f of x plus h. Now it's telling me to subtract the function itself. Well, the function is x squared minus 3. We're going to have a subtraction issue if you don't put it in parentheses. So we're going to subtract f of x squared minus 3. Okay, so once again, for anybody I kind of lost, this statement right here is f of, I'm going to lose you more because it's going to get messy. Ignore the problem in the middle there. That is me doing f of x plus h. I plugged in x plus h into the function, and it became x plus h squared minus 3 instead of x squared minus 3. Then it says to subtract the function. And so that's what I did. And then divide the whole thing by h. All right, so now what we want to do is we just want to simplify this. So watch our common error and just focus on what you're doing. And so I'm squaring that, x squared plus 2xh plus h squared minus the 3. And now I'm going to distribute the negative, negative x squared plus 3 all over h. Quick inspection shows me that some nice things can happen here. And those things are a plus 3 and a minus 3, a positive x squared minus an x squared, which leaves me with 2xh plus h squared all over h. If I'm showing all my work here, I would take the next step and hopefully recognize I have h's in both the top terms. And so I can factor h out, giving me 2x plus h times the h all over h. Factor the h out of this, left me with 2x. Factored one of the h's out, I'm left with 1. And now, hopefully we see, we can cancel out those h's, leaving me with an answer of 2x plus h. Okay. All right, so what I would like you to do is try that on your own now that you've kind of seen me go through it. Again, there's the difference quotient. Make sure you have it written down here. And then give it a shot with the problem 5x minus x squared. Pause the video, give it a try. Okay, let's see how we did. I'm just going to write down the difference quotient here for us so we can see it. First thing I'm going to do is I'm going to plug in x plus h for all the x's. And so that would give me a 5 times x plus h minus another x plus h going in for the other x squared. So that's just the f of x plus h. Now I need to subtract the function. So minus, and I'm going to put it in parentheses because there's more than one term, all over h. All right, now it's just cleaning up and doing some math. Don't do too much at one time if you're feeling a little uneasy because you're going to make mistakes with negatives. So I'm going to take my time and show probably one step more than I normally would. 5x plus 5h minus. Now I'm going to do the FOIL, right, the shortcut. But since it's subtracting multiple terms, I'm going to leave it in parentheses. X squared plus 2xh plus h squared minus, and I might as well, since there's nothing else going on, I'll just distribute it now, minus 5x plus x squared. And now I'm going to take one extra step and distribute the negative. 5x plus 5h minus x squared minus 2xh minus h squared minus 5x plus x squared all over h. All right, lots of stuff should cancel. Negative 5x and a positive 5x. Negative x squared and positive x squared. And I guess that's it. Leaving me with 5h minus 2xh minus h squared all over h. I'm going to factor an h out of every term on the top. Here's a little secret. If you get to this stage and you cannot factor an h out of everything on top, then you've done something wrong. Likely it's a negative issue or you didn't do the shortcut right for squaring a binomial. So I factor out that h. I'm left with 5 minus 2x minus h all over h cancels out. And there's my answer. 5 minus 2x minus h. And this last one, we are going to do the same thing. The more you write down something new, the quicker it will be that you remember it. So I'm just going to write it again for us here. Okay. Looks like I've got 1 over. Replace the x with x plus h. And then subtract the function. So far, so good. But now I've got a little dilemma in front of me. I've got some fractions, and in fact, I've got a compound fraction within a fraction, so lots of reasons to be unhappy here. So I think what I'm going to do is I'm going to focus on the top and subtract those. So I need a common denominator. And so we need to get a common denominator. There's a lot of ways to mess this up. Let's just stay focused on what we want to do here. Even though this is an x right here and this is an x plus h, and it would feel like we could just add an h here, there is no rule that says we can add h and add h. Like that doesn't work. And we can talk about why that doesn't work if we need to. But what we can do is if we were to multiply this side right here by x plus h, and if we multiply this guy by x, then they would both have an x times x plus h. And that would be the common denominator. So then I need to multiply top and bottom. Because when I do this, I can only multiply by the number 1. And x plus h over x plus h is 1. X over x is 1. And so what do I have? I end up getting, in the numerator of this first fraction, I get an x over x times x plus h. Minus, in this one, I get an x plus h times 1 over the same denominator, which was the whole point. And I'm going to move over here. Now I can subtract the top, but be careful. Since we're subtracting and there's 2 terms on what we're subtracting, we would end up getting x minus h over the common denominator all over h. Looks pretty ugly. We're not done. Looks like I can simplify the top of this right here and make it negative h over x times x plus h, and the whole thing is divided by h. All right, we are sitting here with a fraction within a fraction, and we should recognize that when you are dividing fractions, we can do this simpler by multiplying by the reciprocal. So this is my numerator, right? And this is my denominator. So I'm going to take the numerator and not change it. And now I'm going to multiply by 1 over h instead. And my h's cancel, and I'm left with negative 1 over x times x plus h. All right. Seems like a lot, especially coming out of summer, but this is doable math. We just have to focus on what we need to do and not make up our own math steps. All right. We'll be working on this in class. Feel free to ask questions if you need some support.